Turing machine that accepts the language and it was like this. Like that. Even if it's not, this will work. Yeah? Okay. All right. So the first thing that we need to do is we need to figure out what this language is, right? You need to make sure that you actually understand the whole regular expression thing, right? And that's probably the most important part of this class in many ways, because a lot of the stuff that I'm going to do, I'm going to show as regular expressions, right? So give me some strings that are actually in this language, right? Right. So A, B. So actually, before I say that, let's pause and say, what does the plus sign really mean in this case? It's kind of an or, right? So it's strings in this language, and the union of the two. So far, so good? Okay. All right. So some strings in this language are A, B. What else? You guys, there's only 4 of you. You got it. Say again. A, B, right. Come on, help me out, guys. A, B, excellent. Let's see, is lambda part of it? That's always a really good question to ask yourself every single time. Is lambda part of it? So, yeah, I think so, right? You guys agree with me? Yeah. And then there's a bunch that go in there, right? So there would be like BA, and so on. And I think actually on this question for Turing machine, I said that you could think non-deterministically, right? And for a Turing machine, now this is where you get out your cheat sheet, because you've written down some sort, right? You have 5 pages of whatever you want on it, right? So you just help me out and remind me. So the Turing machine commands look something like this. You know, if I see, I think this is what a Turing machine command looks like, and you guys tell me if I've got it right. So if I see like an A on the tape, I replace it with an A and move right or whatever. Is that the notation? Okay. All right. So when I said think non-deterministically, what I was trying to kind of hint at was, look, you can sort of decide, when we talk about non-determinism, you may not necessarily know which way you go at first, right? And in fact, I suppose it's not even non-deterministic here. Let's think about the Turing machine. We've got this tape, right? Yeah? If we have this on there, which we need to accept, right? So let's suppose we start here. And a Turing machine always has this halt state, which is the magic, yay, you're in, right? Okay. Everybody has to nod, sorry. Or you have to tell me, no, stop. I don't mind stopping. If you don't know what a regular expression is, we can do that. But I need you all to nod. Okay? All right, so we have this halt state. So let's, what are the possible cases that we're going to accept, right? Either we're going to say, I see a lambda, right? And of course, I promise you with the Turing machine that it's going to be at the front of the string, right? So if it is if it starts with just a lambda, that means it is just lambda. Everybody with me? So lambda is actually a special easy case, right? If I see a lambda, I can just write a lambda, stay put on the tape, right? And go to halt. I accept, right? If the tape head is pointing at lambda, I am done. I accept, because I know lambda's in there. You guys with me so far? Okay. All right. So lambda's a nice, easy case. Then we have all the other cases. Now, depending on the language that we pick, sometimes you need to go through and make sure that the format of the string is correct, right? So for example, in this problem, is it only A's and B's, right? Because if I see a C, I'm done, right? You guys with me? I think we might be able to skip that step for this particular one, right? Because we just really need to say, if the first thing we see is an A, then we'll check that it's got A, B, A, B, A, B, A, B stuff. The first thing we see is a B, we'll check that it's got B, A, B, A, B, A, B, A stuff, right? And if it doesn't make that pattern, we're going to say, I lose. So let's think about this. I'm going to kind of split this off into two kinds of things I'm going to do. This top path will be if I think I'm doing the BA pattern. So if I think I'm doing the BA pattern, right, what do I want? I want to see, actually I guess let's make the top one the AB pattern since that's on the top. Okay. So if I think I want to do the AB pattern, then I got to kind of look for an A, look for a B, right? And keep looking for pairs of A's and B's, right? Until I see what? A lambda, right? If I see a lambda after A, B, A, B, A, B, some number of those, I'm good, I go to the halt state, I'm done, I accept, right? If I see a Q somewhere, well, I just won't have an arrow with a Q, so I'll fall off the thing, right? I won't win. You guys, so far so good? So, for this top one, let's see. If I see a lambda, great. If I see an A, I'll write an A and I'll move my tape head to the right, right? So if we see like A, B, A, B, something like that, right? Then I'll move my tape head to the right. So I was pointing here and now I'm pointing here. But if I just see an A, I can't go straight to halt, right? You guys are with me because we need to see B. And actually, if I think about it, if I see a B, I've completed one AB cycle, right? And if I see a lambda after that, I could go to halt. So I could, you know, my first thought is, okay, if I see a B, I could go back here, right? This is not going to be right to start out with, but this is my scrap work, okay? So I see a B, I will write a B and go right. And then I see an A, B, A, B, A, B, that's all great, and then I see the lambda. Yeah? And I leave. This is great for the left side here. You guys with me? And of course, it sure looks like I could do the same thing where if I see a B, write a B and go right, and then if I see an A, write an A and go right. And this looks pretty good because then I could get the B, A, B, A, B, A, B, A, right? The trouble with this, what's wrong with this? What could I get that I don't want to allow if I do this picture? Yeah, I could get A, B, B, A, right? Because I keep coming back to the start place, right? So I could go A, B, and then say, oh, and now I want a B, A, and now I'll stop. And I don't want to accept that. Does everybody see that I don't want to accept that? So I kind of need to leave this state and have some stuff up here that's for the ABs and some stuff down here for the BAs. And once I've decided I'm doing the ABs, I can't move back. Once I've decided I'm doing the BAs, I can't move back. Are you guys with me so far? Yeah? Okay. So let's change this a little bit. I guess we've got to kind of can't go back here. And boy, it's going to be hard to draw all the arrows, but we'll figure it out. Okay, so if I have an A, I go there. And if I have a B, I'll write a B and go right. And I'll end up here. So I don't know, 1, 2. And if I see just an A and a B, and then lambda, I want to accept, right? So I guess what I'm going to do is I'm going to do an arrow like this, and I'm going to kind of, no. I'm trying to get to halt without crossing lines. So let's say I will go like this. Right? And that'll be if I see a lambda, write a lambda, and stay put. There's nothing magical about staying put. I could go right if I wanted to. It just feels nice to stay put. You guys with me so far? Okay, so that gets me just the string AB, but what if I have AB, AB? What can I add to this to make it work?
3 to 2.
Yeah, go back from 3 to 2, right? And make that my loop. Because if I go from 3 to 2 and I say, all right, if I have another A, write an A and go right, then I can't get back here, so I could only see like AB lambda or AB, 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 AB lambda. And that's the only way I'm going to get out of there. You guys kind of with me? We need 4 nods. I don't have 4 nods yet, yeah? Okay. And so I think what we're going to do is exactly the same thing down here for the BA part, yeah? So what do we got? We have, there's 4. Am I 4? Yes. And this one is going to be if I see a B, write a B and go right. If I see an A, write an A and go right. If I see a B, write a B and go right. And am I done? No, what's missing? Yeah, I gotta have that out for lambda, right? So where do I say if you see a lambda, get out of here? What state? Yeah, 5, right? So if I see a lambda, write a lambda, and I mean, I could write anything here, right? Stay put, go right, go left, I don't care. It's the last step I'm gonna call. I'll say stay put because why not? But, so yeah, I think that was it. How does that feel? Questions? The basic idea with any Turing machine problem, right? Any Turing machine problem is what you want to do is you want to say, all right, what's the pattern? What do I need to do? Let me make sure, always look for like the special cases, like looking for lambda was a great idea, right? Because you always want to say, is lambda in there? Did I catch it? Right? Or is lambda not in there? Do I accept lambda by mistake? Right? And then after that, it's a matter of kind of a couple of things. Number one, remember that whenever, halt state is it. If you get to the halt state, like if we wanted to accept all strings that, start with an A and then have whatever we want in them, right? We could have an arrow from 2 to H, right? That says no matter what you see on the tape, right? Write an X and stay put. Go straight to the halt. Doesn't matter if there's 5,000 characters in my string. If my language is start with an A and then anything after it, and I go to halt, I just look at the first letter. If it's an A, I'm good. I'm done, I accept. You guys with me? It's different. It's not a double circle anymore. It's just a stop.